So that's what we're going to be working with this whole unit, is a system of equations. And the main idea of the system of equations is that we're able to find solutions to the system. Okay, so most of your practice work or most of your notes, the directions are going to tell you to find a solution. Okay, so we need to know what that means as well. So a solution to the system a solution to a system means that we have values for the variables to make all equations true. Now, a system of equations could look like 2 equations. It could look like 3 equations. When I was in high school, that's what our math teacher kind of threatened us with. When we weren't behaving, that he gave us systems of equations homework, and it would take up 2 or 3 pages because it'd be 5 or 6 equations long. Okay, I'm not going to do that with you guys because that was just nuts and it made me hate math. Okay. But in those cases, when there was 5 or 6, sometimes there was 8 variables. Sometimes there was 7 variables. This year, because this is your first time doing systems of equations, we're only going to be dealing with 2 equations at a time and only 2 variables. When we graph, what 2 variables do you think we might use? X and Y. So all of our solutions this year will look like X, Y. They'll look like an ordered pair. All right, so for our first example, we're going to pause here to do an example. We're going to ask ourselves the question, is it a solution? And we're going to have 2 equations here, and I want to know, does the ordered pair work for both of the equations? Okay, so our system is y equals 2x minus 3. What form is that in? Yeah, y equals mx plus b. We call that slope-intercept form. Okay, what about this one? 4x plus y equals 3. Good, that one's in standard form, that ax plus by equals c. So with a system of equations, usually we see those systems stacked on top of each other. So these are the 2 systems. Sometimes you'll see a bracket, especially if there's a lot of them. Since we're only doing 2 systems this year, you won't see that very often, that bracket. But once you go to Algebra 2, when there's 3 or 4, you'll see that bracket that groups them all together at the same time. All right, so our question for this first one is 2, 1 a solution to the system. And this is just like what we did in our warm-up. Okay, so we're going to take our first equation, y equals 2x minus 3. I'm going to do it a little off to the side because we have to do it for both equations. And then we're going to do the 4x plus y equals 3. And in order for it to be a solution, it has to work for both those equations. So which one of these is my x? 2. Which one is the y? 1. So we're just going to replace those and see if we get a true equation or a false equation. So in this first one, instead of y, what number could I put there? 1 equals 2 times, what's our x? 2 minus 3. There's nothing really to do on this side with the 1, so we're going to leave that 1 be. What is 2 times 2? 4. And 4 minus 3. is 1. So does that make a true equation? Yep. So it works for 1. It's a solution to one equation. We don't know if it's a solution to both, though. So for our second one, we're going to do the same idea. We're going to plug in that x and that y and see does it work. So we'd have 4 times, what is our x? 2 plus, what's our y? 1. And we want to know, does that equal 3? And some people are at this point where they could just do that in their head. If you still need to take your time to show what we're doing, each step by step, what would we do first?
4 times 2.
Good. 4 times 2.
Plus 1 is 9.
And 4 times 2 is 8. So we get 8 plus 1,
9.
which is 9. Does 9 equal 3? No. So is this a solution to the system? No. That does not work. Okay, let's use the same system and do 1, negative 1. So I'm just going to stack it up over here. Say that was. Okay, go ahead and try plugging those in for those equations. Alright, so when we do this, we're going to plug in that x and y. So this time, what is our x?
Negative 1.
Negative 1. What is our y? Negative 1. So we have y equals 2x plus 3. What is my y? Negative 1 equals 2 times, what's my x? 1. Oh, this was supposed to say minus 3, isn't it? Sorry, I wrote that down wrong. This was a minus 3. Minus 3. My bad. We're getting there. This is just not working as a setup today. I apologize. Alright, so what is 2 times 1? 2. And 2 minus 3? Negative 1. So does negative 1 equal negative 1? Yep, it works for that one. If it didn't work, would we have to check it with the other equation? No, because we just know it won't work, period. Okay, so if it doesn't work for one, we can just be done and say, nope, doesn't work. But if it works, we do have to check it with the other one. So 4x plus y equals 3. Mm-hmm.
4 times 1.
Good. 4 times 1 plus
Plus
negative 1 equals 3. So we're going to substitute them in and then see if they work.
They do.
Does it? What's 4 times 1?
4.
4.
Plus negative 1 is 3.
Good. And 4 plus negative 1 is 3. So is this a solution to the system? Did it work for both?
Yeah.
Yep. So our answer is yes.
Wait, so if it doesn't work the first time, just change it to a random number until it works?
No, these ones you're just going to test. You can't just, well, you could, but there's an infinite amount of numbers you could plug in, and that would just take you your whole life. These ones, you'll be given a point, so you just say yes or no. If right away the answer is no, your answer is no. If it says yes, then we have to check the next one, because if it's yes, no, then it's a no.
Have to do the 2 seconds.
Yep, 2 equations. All right, at this point, if you need to, not if you need to, grab 2 colored pencils. I'm going to use purple and green. We're going to use these 2 colored pencils throughout the rest of the notes. So I would try and grab 2 that you're not sharing with someone. Grab 2 that are just for you. I'm going to use purple and green, but you can use any 2 colors you want. I thought this was going to make a really good station over here, but it does not. It's a rough time. I need this to go. This. I did for a second because I just thought it'd be better than having two cards over here, but that was a mistake. Alright, so for our next, this is our last vocabulary word. So I'm going to go back to my margin here, back on the red part, and put a little dot there. You don't need a whole lot of room for this. So if you're running out of space, 2 or 3 lines will be plenty. We're going to call this graphing systems. And we're going to think if we graph 2 lines, what might that look like when we graph 2 lines? What could those 2 lines be doing?
Crossing.
They could be crossing. So in my first picture here, I'm going to do my green line. And then my purple line. Do they have to be crossing at a certain angle? No, they could just be crossing. So just do your 2 colors. Where they cross that point of intersection, that is your one solution. And remember, how do we show that solution today? That is our x, y. It's an ordered pair. Okay, so one option is that the 2 lines might cross. And how many times can they possibly cross? Just once. Can they cross twice? No, not if they're straight lines. Okay, what's wrong with you? Yeah, there's more in here. Literally a lot. Crazy person. Now I have to go back and I'm going to have to just make sure it gets back in that one, please. Alright, what's another option with lines? They could cross one time. What else could happen?
Parallel.
They could be parallel. What does parallel mean? Yeah, they never touch. They're running right next to each other. So in this problem, if they're never touching like that, how many solutions are they going to have? How many times do they overlap? None. So we're going to call this no real solutions. That's right, when they're parallel, they're going right next towards each other. Okay, and then there's one other option. This option's a little confusing, so I would watch it first before you draw it. Okay? For this option, what could happen is that we have a line, this purple line, and then the green line is right on top of it. They're really the same line. Okay, so I know it's kind of hard to see, but what I did first was the purple line, and then the green line was right on top of it. They're really the same line. So how many points will those 2 lines touch all at the same time?
All of them.
All of them. And how many points are there on a line?
Infinite.
An infinite. What does infinite mean?
Undefined.
Not undefined.
No,
Yeah, it never stops. So this one has infinite solutions. It's going to keep going on and on and on. That's why we have those arrows. It goes on and on and on and on and on in both directions. All right, we are going to keep your color pencils out. On your table, I did pass these out, the 3 graphs. I just trimmed the top and then just trimmed the bottom. And it should fit in your notes, because it's going to take up another page anyways.
it doesn't.
If you cut off the top and the bottom, just a little bit. Cut off where it says name. Yeah. If you just cut off the top and the bottom, it should fit onto your notes page all as one. It doesn't need to be perfect. But just that way it won't take us as much if you cut them all individually. So just trim the top, trim the bottom. Glue it in. Yeah, but you're going to glue it down. You're only C3. Yeah, we're only using one. You're going to need a new page anyway, so you might as well just keep them all together and go on the next page. Takes up a little less space, less time to just glue it all in at once. Yeah, or just glue it in here. And then you glue this into your notebook. I'm gluing. You do need some space for your work, so it doesn't matter which side you do your work on, if you're doing it on the top or on the bottom, on the side or on the other side. What? All right, about 30 more seconds and then we're going to get started. All right. Alright, number 2. This is example 2. We did example 1 on the front side, so we're on example 2. We're going to do 3 examples here, and then we will be moving on to your practice today. Alright, so for example 2, we have two equations. It's one system, y equals 1/3 x plus 4. And y equals negative 5/3 x minus 2. All right. What kind of form are those in when they look like y equals mx plus b? Good, slope-intercept form. So we know our slope and we know our y-intercept right away, which makes them easy to graph. I'm going to do this one in green, so I'm just going to lightly shade it so I know this is the green line. Okay, with that top one, what is my slope? What is my m? Good, 1/3. So that means I'm going to rise 1, run 3. What is my b? 4. All right, so on my graph, where am I going to start? Do I start with my m or do I start with my b? B, and my b is 4, so where am I going to go from the origin to get to that 4? Good, up 4. 1, 2, 3, 4, and we make our point. Okay, from there, how am I going to rise and run? Good, up 1 and then over 1, 2, 3. And we can do that again. Up 1, over 1, 2, 3. Now today it's going to be helpful to go throughout your whole graph as many points as you can. So instead of going up and over, we could go down and then to the left. Good. Down and to the left. And then at this point you just need a straight edge. If that ruler is handy, you can grab that, or you can use the side of your phone, you can use the side of your notebook. All right, now for the next one. What is my m in my next equation here? I'm going to do this one in purple, so switch colors. What is my m for this equation? Negative 5 over 3. So I know which way is it going to be going? Negative. So that means it's going to be going like downhill. Okay, and what is my y-intercept? Negative 2. Okay, so from the origin, where am I going to go to start?
Down 2.
Down 2. Why do I go down 2? It's negative 2. All right, can I go down 5? No, I'm only going to be off by 1, so I can estimate 5 is about at the end of this arrow, 5, and then over 1, 2, 3. Big thing is we want to make sure it's going downhill, so we could estimate that. It's not a great estimation, so where else could I for sure find a point?
Up.
Okay, if I go up 5, which direction do I go?
Negative.
Negative.
It's the point closest.
So in this system, when we graphed it, how many solutions do we end up with?
2.
How many times do they cross?
1.
Once. Okay, so we want to say what is that solution. So back over here under my problem, my solution is an ordered pair. And this is where we start from the origin. So from the middle, am I going to go left or right? Left 3, then up 3 to get that point where they cross. So negative 3, positive 3. All right, we have 2 more. Does everyone see where we got that negative 3 from? Okay, that's where they cross. All right, we have 2 more. Yep. Can't do that. Doesn't work that way. You can go up 5 and then go left 3. Otherwise, you're changing the slope completely. All right, for our next one, we got number 3. If you want to try and work a little bit ahead on this one, you can. If you want to see if your graphing is good. Our first equation is y equals negative x plus 4. And then we have 4x minus 3y equals negative 9. So y equals negative x plus 4. 4x minus 3y equals negative 9. So is that first equation in a spot where we like to graph it? Like, do we know the m? Do we know the b? Yeah, what's the m? How did you know it was going to be a negative 1? Because negative 1. Because when we see that negative sign, what number can we always sneak in there? 1. A 1. Okay, so we can sneak in that negative 1 if we need to. What is my b? 4. So that one's easy to graph. We can do it right away. Where are we going to start? 4. So from that origin, we count up 4. 1, 2, 3, 4. Do you guys want to go up 1 or down 1?
Down 1.
Okay, if we go down 1, then how many are we going over? What number can we always put underneath 1? So we could go down 1, and then are we going to go left or right?
Right.
right one, because we want it to be going downhill. So down 1, right 1. Down 1, right 1. You could go in the other direction as well, but once you have so many, it should be easier to at least see where your points would go. Make sure your line goes throughout the whole graph, just in case it crosses at a point that you haven't made yet. Alright, what is the issue with this one? What? The y isn't first. What form is it in? Standard form. Do we have an easy way of graphing standard form?
Yeah, that's the y and the x. No, we don't.
No, we don't. So we want to solve it for what? For y. We want to make it into y equals mx plus b. So I'm going to draw my line down the equal sign. I went back to pencil for this because otherwise it just gets a little sloppy. Okay, do I want to get rid of that 4x first or the 3y? Good, 4x. How do we get rid of a positive 4x? We do it on one side. Beautiful. So I'm still left with negative 3y. Just to save us some time, should we put the 9 first or the 4x? Yeah, just to save us a little bit of time. Negative 4x minus 9. You want to work ahead? Go ahead. That would be if we were doing a minus 3. Divide. Good. Divide by what? Negative 3. When we divide, what do we divide by? I'm sorry, which parts do we divide? All of them, yeah. Sorry. We divide everything by negative 3. So we end up with y equals, can we do 4 divided by 3? Nope. But we do know a negative divided by negative is a positive. So we're going to simplify that to a positive 4/3 x. And then what's negative 9 divided by negative 3? Positive 3 or negative 3? Oh, no. Oh, no. You guys, can you forgive me? This was supposed to be a positive 9 to start with. So just make this a plus here instead of a minus. Sorry. Okay, so now, if it's a positive 9 divided by negative 3, negative 3. Alright, so now we're ready to graph it. Now it looks like y equals mx plus b. What is our m? 4/3. And what is our b? Negative 3. Yikes. My bad. Sorry, guys. I read my notes wrong. Alright, so where are we going to start on our graph? Negative 3. And then we're going to rise 4 and run 3 to the right. And that's really nice. Since we made all of our points going down so many, we could have just gone down 1 over 1 and ended with that green. But because we kept doing it, we can see where those two lines are going to cross. That makes it really easy on us. We don't have to make any guesses about where that point might be if our line was drawn poorly. But because we drew all those points, we can see, yep, that's where it crosses. So what is our x and what is our y of that point? Good. 3, 1. So if we took time to plug it in like we did before, if I put in 3 in for both these x's, if I put 1s in for the y's, it would work for both. We'd get true, true. All right, we have our last one. This one's going to go by a little bit quicker. I know it's going to feel like it won't, but it's math, so nothing ever feels like it goes by quick, right? Miss Merrill, you're so funny. Thanks, guys. Okay, number 4. Last one for today. Y equals negative 5/4 x minus 3. And that is a minus. I'm double checking right now. I wrote it down right. Good job, Miss Morrell. Thanks. Okay, and now this next one is 10x plus 8y equals negative 24. If you want to try and work ahead, you can go for it. If you're still like, what the heck are we doing? Hang out with me. So we're going to graph both of these on the same graph because that's what a system means. A system means we're going to work on them at the same time. So I'm going to do this green one first. Remember, this is y equals mx plus b. So what is our b? Negative 3. So remember on our graph, our y-axis is this one that goes up and down. So to get to negative 3, from the origin, we're going to go down 1, 2, 3. And then our slope is negative 5/4. Can I go down 5? No, and this one I'd really have to guess because it'd be really off the graph. So instead of going down 5, we're going to go up 5. But to make it go downhill, should we go left 4 or right 4? Left. And those are the only 2 points we can get on the graph right now with this one. All right, last equation we're graphing. 10x plus 8y equals negative 24. That is not the easiest to graph. In order to graph that, we'd have to find the x and the y-intercept, and that would end up actually being a fraction, and it would turn into this whole thing, and it'd be too much. So the easiest way to graph this is by solving for y. So best friend of our y is that 8. We're going to keep the 8. How am I going to get rid of the 10x? Good. Minus 10x on both sides. Just to save us some time, we're going to do that minus 10x plus negative 24. We could put the 24 first, but in the end, we'd have to take a step to switch them, which is fine. Just takes an extra step. And then what? Good. Divide by 8 on everything. On both sides, yep. Can we do 10 divided by 8? No. Can we simplify it? Yeah, what can you divide 10 and 8 both by? 2. What's 10 divided by 2? 5. What's 8 divided by 2? 4. X plus, what's negative 24 divided by 8? Negative 3. Hassan, notice something before we even got a chance to even practice it. What do you notice about this equation? Yeah, that's the same. So if we graph it, we'd start at negative 3. We'd rise 5 and run 4 to the left. It's the same line. So when we talk about solutions here, what is the answer? How many solutions does this one have? Good, infinite. So that would be our answer, is infinite solutions. Another way you might see that written, either like on a test or on homework, I usually say infinite solutions, but other teachers might say infinitely many. It's the same thing. Okay, so infinite solutions or infinitely many solutions. Alright, so you have 6 problems for homework?
No.
It's not. Go ahead and put your name on it. You want to get started on the graphing one, you can. I know number 1 looks super confusing, so we'll do that one together because in my head it made a lot of sense, and then once I handed it out to kids, they were like, what the heck? And then I was like, yeah, what the heck? Who made that problem? Because it's nuts. Alright, so this one is a joke worksheet. You're going to answer the question, what's in a ghost's smells? So at the end, you're going to cross out the answers that you have, and the letters remaining, the letters left over at the end will spell out the joke. So go ahead and put your name on it.
It's a boot.
Okay, number 1, for some reason it was supposed to be the easiest, but got really confusing. So let's just do number 1 together real quick, so you can figure out kind of what it was saying. Alright, so number 1, it says determine if which ordered pair is a solution to the system. So one of these is going to be our answer, hopefully. So here our x is 1, our y is -3. So they already took the time to do y equals -2x minus 1. And instead of y, they put in -3. And instead of x, they put in a 1. Now we just have to figure out what this side is equal to. So what is -2 times 1?
-2.
-2.
-1 is -1. So
If I have 2 negatives and I subtract another,
-3.
it ends up being -3. So does it work for this one? Yes. But in order for it to be a solution to the system, it has to work for both of them. So again, over here, they took the y, they put in a -3. They took the x, they put in a 1. So what's -1/2 times 1? Just -1/2. If I start at 2 and I go down by a half, just 1.5. If I think about it as starting at 2, that's the way my brain works. If I start at 2 and I take away a half, you'll be at 1.5. So does that equal? No. So is this a solution to the system? No. So I'm going to cross that out. Didn't work. So hopefully this next one will work. Otherwise our answer might be no solutions. So this time we have -2 for our x. We have 3 for our y. They already plugged it in for us on this first one. They made it easy for us.
Yes.
So what is -2 times -2?
Normal 2. Or normal 4.
Positive 4. And what is 4 minus 1? 3. So did it work? Yep. Okay, now on this one we got to plug in our y and our x. So what is our x? -2. Sorry, I started with my x. That's the way my brain works. What is my y? 3. Some people might start there because it's left to right. All right, what's half of 2? 1, and a negative times a negative is a positive. So it's a positive 1.
Plus 2.
And what's 1 plus 2? 3. So does 3 equal 3?
Yes.
So is this a solution?
Yes.
All right, so that is our answer. So on the back side, where you see -2, 3, you're going to cross that out. After you've gone through and you cross out the ones that you have as answers, the leftover letters will spell a word out. Okay? Okay, so number 2, same idea. 3 and 4 should be pretty easy. When you go on to the back side, that's where you have to start solving an equation. Number 3 and 4 shouldn't take you too long to graph because they're already in slope-intercept form. Let me know if you need help. And then you just keep packing them? I do that too.